Welcome, gentle traveler, to the quietest corner of the night. Perhaps you are lying in bed, the world hushed around you, or maybe you are simply pausing, letting your thoughts drift like leaves on a slow, invisible current. Tonight, we will journey together, not with rockets or telescopes, but with wonder, into the heart of the cosmos, to witness one of the universe's most beautiful miracles, the birth of stars in cosmic clouds. This is not a journey of engines and fuel, but of curiosity. We'll float on questions, letting them carry us outward, past the familiar constellations, beyond the reach of our sun, past the swirling arms of our galaxy, and into the deep, dark nurseries where stars are born. We'll ask questions that have haunted humanity for centuries. We'll listen for answers in the silence between the stars. Imagine for a moment the comfort of your room fading away. The walls dissolve, the ceiling lifts, and above you stretches the vast ancient sky. Stars blink softly, scattered across a canvas so deep it seems endless. But where do these stars come from? How does the universe, in its quiet patience, turn clouds of gas and dust into blazing suns? What is the story of a star's first breath? This is a question as old as wonder itself. For as long as there have been people to look up at the stars, there have been stories about their origins. The night sky is not just a ceiling, it is a horizon, a boundary between the known and the unknown, the safe and the mysterious. It is the first edge we ever meet. As you settle in, know that this space is for you, a place where science and imagination meet, where your mind can rest even as it wanders. Take a slow breath. Let the night wrap around you. The universe is waiting, and together we'll drift into its gentle darkness. But before we go, let's pause and look up. The journey begins not with a leap, but with a gaze, a simple act of wonder. What do you see when you look at the night sky? And what secrets does it hold about the nature of creation and light? The night sky is the oldest storybook, its pages turned by every generation that has ever looked up in wonder. Before there were telescopes, before there were maps or even words for the stars, there was the simple act of gazing upward, letting the eyes adjust to the darkness, and feeling the world grow larger with every blink. The sky above is not just a ceiling. It is a horizon, a boundary between the known and the unknown, the safe and the mysterious. It is the first edge we ever meet. Imagine yourself lying on cool grass, the earth solid beneath you, the air tinged with the scent of night. Above, the sky stretches on, a deep velvet scattered with pinpricks of light. Some stars are bright and bold, others faint and shy, but all of them are ancient. Their light has traveled years, centuries, even millennia to reach you. Each star is a messenger from the past, a silent witness to the birth and death of worlds. For our ancestors, the night sky was a map and a mystery. They traced patterns in the stars, drawing lines between them to create stories. Hunters and bears, queens and dragons, heroes and monsters. These constellations became guides for travelers, calendars for farmers, and comfort for dreamers. The sky was a clock, a compass, a canvas for the imagination. But it was also a horizon, a place where the world seemed to end and something else, something vast and unknowable, began. In every culture, the edge of the sky was a place of wonder and fear. Some believed the stars were holes in a great dome, letting the light of heaven shine through. Others imagined the sky as a river, its currents carrying the souls of the departed to distant shores. There were stories of gods who lived beyond the stars, of monsters who lurked at the edge, of heroes who dared to journey past the horizon and never returned. The night sky was both a promise and a warning. There is more than you can see, more than you can know. As science grew, so did our sense of the horizon. The invention of the telescope revealed that the sky was not a dome, but a vast expanse filled with countless stars, each a sun in its own right. The Milky Way, once thought to be a river of milk spilled across the heavens, was revealed to be a galaxy, a swirling city of stars, billions strong. And beyond our galaxy, more galaxies, each one a universe of its own, scattered across the darkness like islands in a cosmic sea. But even as our vision expanded, The sense of horizon remained. No matter how far we see, there is always a limit. A place where the light grows faint, where the stars blur into mist, where the questions outnumber the answers. The night sky is a reminder that every discovery brings a new edge, a new boundary to explore. Tonight, as you look up, let your eyes wander from star to star. Notice how some twinkle and others shine steady. Notice the way the sky seems to curve, wrapping around you like a gentle embrace. This is your first horizon, the edge of your world. Beyond it lies the unknown, the uncharted, the infinite. But the horizon is not just out there, in the sky. It is also within you, in the questions you ask, in the dreams you dare to dream. Every time you wonder where stars come from, you are reaching for the edge, stretching your mind to meet the universe. The night sky is both a mirror and a window, a reflection of your own curiosity and a portal to something greater. As you breathe in the quiet of the night, remember that you are not alone. All over the world, people are looking up at the same sky, tracing the same constellations, asking the same questions. The horizon connects us across time and space, across cultures and generations. It is the place where our stories begin and where they are always unfolding. The night sky is patient. It waits for you to notice, to wonder, to ask. It does not rush. It does not demand. It simply is. A gentle invitation to explore, to imagine, to rest in the presence of something vast and beautiful. And so, as you lie here, let the horizon draw you in. Let it remind you that the universe is not a closed room, but an open field. That every edge is a beginning, not an end. That the night sky is not just a backdrop for your life, but a companion on your journey. If the night sky is a storybook, then nebulae are its most beautiful illustrations. Vast, colorful clouds that paint the darkness with mystery and promise. The word nebula comes from the Latin for cloud, and that is exactly what these cosmic wonders are. Immense clouds of gas and dust, drifting through the galaxy, glowing softly or hiding in shadow, waiting for the right moment to give birth to new stars. Nebulae are the universe's great nurseries, the places where creation begins. They come in many shapes and sizes, each with its own story. Some are bright and bold, shining with the light of newborn stars. Others are dark and cold, veiling their secrets in shadow. Some are sculpted by the winds of dying giants, others by the gentle pull of gravity, still others by the shockwaves of ancient explosions. Each nebula is a unique work of art, a cosmic canvas painted by time and energy. There are several types of nebulae, each with its own role in the story of starbirth. Emission nebulae are perhaps the most famous, glowing with the light of ionized gas. These nebulae are often found near hot young stars, whose intense ultraviolet radiation strips electrons from atoms, causing the gas to shine in brilliant reds, pinks, and greens. The Orion Nebula, visible even to the naked eye on a clear winter night, is a classic example, a glowing cradle where hundreds of stars are being born. Reflection. Nebulae are more subtle, shining not with their own light, but with the light of nearby stars reflected off tiny dust grains. These nebulae often appear blue, because blue light scatters more easily than red. The Pleiades, a cluster of young stars surrounded by a faint blue haze, is a beautiful example of a reflection nebula at work. Then there are dark nebulae, clouds so thick with dust that they block the light of stars behind them, creating inky silhouettes against the brighter background. The Horsehead Nebula, with its iconic shape, is one of the most famous dark nebulae, a shadowy figure standing guard in the constellation Orion. These dark clouds are the true wombs of starbirth, hiding the earliest stages of creation from prying eyes. Planetary nebulae, despite their name, have nothing to do with planets. They are the glowing shells of gas ejected by dying stars, brief and beautiful reminders that even in death, stars can create new wonders. The Ring Nebula and the Helix Nebula are haunting examples, cosmic ghosts drifting through the galaxy, lighting the way for the next generation. Supernova remnants are another kind of nebula, born in violence rather than peace. When a massive Star explodes. It sends shockwaves through space, sweeping up gas and dust, creating intricate filaments and glowing knots. The Crab Nebula, the remnant of a supernova seen on Earth in 1054, is a swirling tapestry of energy and matter, a reminder that destruction and creation are often intertwined. Nebulae are not just beautiful, they are essential. They are the raw material from which stars, planets, and even life itself are made. The gas in a nebula is mostly hydrogen, the simplest and most abundant element in the universe. Mixed in are traces of helium, carbon, oxygen, nitrogen, and other elements, some forged in the hearts of ancient stars, others scattered by supernovae, all waiting to be gathered and transformed. But nebulae are also fragile, shaped by the forces around them. The winds from nearby stars can sculpt them into pillars and arcs, while gravity pulls them into knots and clumps. Magnetic fields thread through them, guiding the flow of gas and dust. Shockwaves from supernovae can trigger new waves of star formation, setting off a chain reaction that echoes across the galaxy. As you lie here, let yourself imagine drifting through a nebula. Picture the colors: soft reds and pinks, deep blues and purples, glowing greens and golds. Imagine the silence, the vastness, the sense of possibility. The night sky is never truly dark, for it is alive with the light of nebulae, the gentle glow of creation, the quiet hope that every cloud is a cradle, every shadow a promise, every mystery an invitation. Nebulae are also a reminder that the universe is always changing, always becoming. The clouds we see today will not last forever. Some will collapse to form new stars. Others will be blown apart by stellar winds. Still, others will drift quietly, waiting for their moment. The story of a nebula is the story of transformation, of patience, of the gentle unfolding of time. Tonight, as you rest, let the cosmic canvas of nebulae fill you with wonder, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always painting, always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the ingredients of a star, the gas, the dust, and the gravity that come together in the darkness to ignite the light of a new sun. The universe is waiting, and the next horizon is calling. Every star, no matter how bright or massive, begins with the simplest of ingredients: gas, dust, and gravity. These are the raw materials of creation, the building blocks from which the universe sculpts its most luminous wonders. But how do these humble elements come together to ignite the fires of a star? The answer is a story of patience, chance, and the quiet, persistent pull of gravity. The most abundant ingredient in the universe is hydrogen, the lightest and simplest atom. It was born in the first few minutes after the Big Bang, when the universe was still a hot, dense soup of particles. As the cosmos expanded and cooled, protons and electrons found each other, forming hydrogen atoms that would drift through space for billions of years. Helium, the second most common element, was also forged in those early moments, along with trace amounts of lithium. These elements are the primary fuel for star formation, but hydrogen and helium alone are not enough. Scattered among the gas are tiny grains of dust, microscopic particles of carbon, silicon, oxygen, and other elements. These grains are the ashes of ancient stars, the remnants of supernovae, the cosmic seeds that help cool and clump the gas. Dust is both a veil and a catalyst, hiding the earliest stages of starbirth from view while helping to shepherd the gas into denser regions. Gravity is the silent architect of the cosmos. It is the force that draws gas and dust together, that shapes clouds into knots and filaments, that sets the stage for creation. In the vastness of a molecular cloud, a cold, dark region of space where star formation begins, gravity works slowly, almost imperceptibly, pulling atoms and molecules toward each other, building up regions of higher density. These regions, called clumps or cores, are the cradles where stars will one day be born. But gravity does not work alone. The gas in a molecular cloud is cold, just a few degrees above absolute zero, but it is not still. It swirls and eddies. Buffeted by turbulence, threaded by magnetic fields, stirred by the shock waves of distant supernovae. These motions can help or hinder the collapse of a cloud, sometimes triggering star formation, sometimes tearing clouds apart. The balance between gravity, turbulence, and magnetic fields is delicate, a cosmic dance that determines when and where stars will form. As a clump of gas and dust grows denser, it begins to collapse under its own gravity. The collapse is not uniform. Some regions fall faster than others, creating a web of filaments and knots. As the gas falls inward, it heats up, its pressure rising, its temperature climbing. At the center of the collapsing clump, a dense, hot core forms, a protostar, the embryo of a future sun. But the journey from cloud to star is not easy. The collapsing gas must shed its excess energy, radiating heat into space, often with the help of dust grains that absorb and re-emit the energy as infrared light. The cloud must also lose angular momentum, the tendency to spin faster as it contracts. This is often accomplished by forming a disk of gas and dust around the protostar, a structure that will one day give birth to planets, comets, and asteroids. The ingredients of a star are simple, but the process is complex. It can take millions of years for a cloud to collapse, for a protostar to gather enough mass, for the conditions at its core to become hot and dense enough to ignite nuclear fusion. Along the way, many clumps will fail, dispersing back into the cloud, waiting for another chance. Only a few will succeed, lighting the darkness with the first glow of a newborn star. As you lie here, let yourself imagine drifting through a molecular cloud. Picture the darkness, the cold, the silence. Imagine the gas and dust swirling around you, the gentle pull of gravity, the slow gathering of material. The night sky is never truly dark, for it is alive with the promise of creation, the gentle glow of possibility, the quiet hope that every atom, every grain of dust, every whisper of gravity is part of a story that is always unfolding. The ingredients of a star are also the ingredients of life. The carbon in your cells, the oxygen in your breath, the iron in your blood, all were forged in the hearts of ancient stars, scattered across the galaxy, gathered into clouds, and born again in new suns and planets. You are quite literally made of stardust, a child of the cosmos, a traveler on the road of light. Tonight, as you rest, let the story of star birth fill you with wonder, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the dark clouds where stars begin, the hidden nurseries where the first breath of a star is drawn. If you look up at the night sky from a truly dark place, you might notice that the Milky Way is not just a river of light, but also a tapestry of shadows. These are the dark clouds, vast, cold, and silent, where the story of every star truly begins. They are the universe's hidden nurseries, the places where creation is cradled in secrecy, where the first breath of a star is drawn in darkness. These dark clouds are known as molecular clouds, and they are among the coldest and densest places in the galaxy. Unlike the bright, glowing nebulae that catch our eye, molecular clouds are almost invisible, their presence revealed only by the way they block the light of stars behind them. They are made mostly of molecular hydrogen, with traces of helium, carbon monoxide, ammonia, and other simple molecules. Mixed in are tiny grains of dust, carbon, silicates, ices, that help cool the cloud and shield it from the harsh radiation of nearby stars. A single molecular cloud can be enormous, spanning dozens or even hundreds of light years, containing enough material to make thousands of stars like our sun. Yet, for all their size, these clouds are fragile, easily disrupted by the winds of massive stars, the shock waves of supernovae, or the gentle tug of gravity from passing objects. The balance between collapse and dispersal is delicate, a cosmic dance that determines when and where stars will be born. Within these clouds, the darkness is profound. Sunlight cannot penetrate, and even the light of the brightest stars is swallowed by the dust. The temperature drops to just a few degrees above absolute zero, and the pressure is low. But in this cold, quiet environment, gravity begins its patient work, gathering gas and dust into denser regions called clumps or cores. These are the seeds of future stars, the places where the story of creation will unfold. The process is slow, almost imperceptible. Over millions of years, the clumps grow denser, their gravity pulling in more and more material. As the density increases, the temperature at the core begins to rise, and the first hints of light, faint infrared glimmers, begin to escape. But for now, the star is still hidden, wrapped in layers of dust and gas, its birth a secret kept by the darkness. Astronomers have learned to peer into these dark clouds using special telescopes that can detect infrared and radio waves. These wavelengths can slip through the dust, revealing the hidden structure of the cloud, the filaments and knots where stars are forming. The images are haunting, ghostly shapes, glowing softly in the darkness, hinting at the drama unfolding. Within, some of the most famous star-forming regions in the sky are dark clouds. The Horsehead Nebula, with its iconic silhouette, is a dense cloud of dust and gas in the constellation Orion. The Pipe Nebula, winding through the heart of the Milky Way, is a river of darkness against a sea of stars. The Coal Sack, visible from the southern hemisphere, is a black patch in the sky, a place where the light of the galaxy is swallowed whole. But not all dark clouds are destined to give birth to stars. Some will be torn apart by the winds of nearby giants, their material scattered back into the galaxy. Others will drift quietly, waiting for the right moment, the right nudge, the right balance of forces. The story of star birth is a story of patience, of chance, of the quiet persistence of gravity. As you lie here, let yourself imagine drifting through a dark cloud. Picture the silence, the cold, the sense of possibility. Imagine the gas and dust swirling around you, the gentle pull of gravity, the slow gathering of material. The night sky is never truly dark, for it is alive with the promise of creation, the gentle glow of possibility, the quiet hope that every shadow is a cradle, every darkness a beginning, every mystery an invitation. The dark clouds are also a reminder that creation often begins in silence, in places hidden from view, in moments of stillness and waiting. The stars we see tonight were once secrets kept by the darkness, dreams waiting to be born. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. Tonight, as you rest, let the story of the dark clouds fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The next step in our adventure is to explore how gravity works in space, the quiet gathering that sets the stage for the birth of a star. The universe is waiting, and the next horizon is calling. In the vast, cold darkness of a molecular cloud, where sunlight cannot reach and silence reigns, a quiet force is always at work. This is gravity, the gentle, patient hand that gathers the ingredients of a star, shaping the future in the stillness of space. Gravity is the architect of the cosmos, the sculptor of galaxies, the silent conductor of the symphony of creation. Gravity is the weakest of the fundamental forces, but over great distances and with enough mass, it becomes irresistible. In the emptiness of a molecular cloud, where atoms and molecules drift for millions of years, gravity is the only force strong enough to bring order to chaos. It begins with the tiniest of nudges, a passing shockwave from a supernova, the collision of two clouds, or the slow cooling of gas. These disturbances create regions of higher density, tiny seeds around which gravity can begin its work. As gravity pulls gas and dust together, the material in the cloud begins to clump. The process is slow, almost imperceptible, but relentless. Over thousands or even millions of years, the clumps grow denser, their gravity pulling in more and more material. The cloud becomes a web of filaments and knots, each one a potential cradle for a new star. The collapse of a cloud is not uniform. Some regions fall faster than others, creating a tapestry of dense cores and empty voids. As the material falls inward, it heats up, its pressure rising, its temperature climbing. At the center of each collapsing core, a dense hot region forms, a Orion Nebula. Protostar, the embryo of a future sun. But the journey from cloud to star is not easy. The collapsing gas must shed its excess energy, radiating heat into space, often with the help of dust grains that absorb and re-emit the energy as infrared light. Gravity also has to contend with other forces. The gas in a molecular cloud is not still. It swirls and eddies, buffeted by turbulence, threaded by magnetic fields, stirred by the shock waves of distant supernova. These motions can help or hinder the collapse, sometimes triggering star formation, sometimes tearing clouds apart. The balance between gravity, turbulence, and magnetic fields is delicate, a cosmic dance that determines when and where stars will form. As the core collapses, it begins to spin, conserving angular momentum. This spin causes the material to flatten into a disk around the forming protostar, a structure that will one day give birth to planets, comets, and asteroids. The disk is a place of chaos and creativity, where dust grains collide and stick, where gas flows and eddies, where the seeds of future worlds are sown. The collapse continues until the pressure and temperature at the core become high enough to ignite nuclear fusion, the process that powers every star. But before that moment, the protostar is still hidden, wrapped in layers of dust and gas, its light a secret kept by the darkness. Only in the infrared can astronomers glimpse the faint glow of the forming star, a promise of the brilliance to come. Gravity is not just a force. It is a story. It is the story of patience, of persistence, of the quiet gathering that sets the stage for creation. It is the reason the night sky is never truly dark, for it is always at work, always shaping, always inviting new stars to be born. As you lie here, let yourself imagine the slow gathering of a star. Picture the darkness, the cold, the silence. Imagine the gas and dust swirling around you, the gentle pull of gravity, the slow gathering of material. The night sky is alive with the promise of creation, the gentle glow of possibility, the quiet hope that every atom, every grain of dust, every whisper of gravity is part of a story that is always unfolding. Gravity is also the reason you are here. The atoms in your body were gathered by gravity, forged in the hearts of stars, scattered across the galaxy, and brought together again in the cradle of Earth. You are, quite literally, a child of gravity, a traveler on the road of light, a participant in the dance of creation. Tonight, as you rest, let the story of gravity fill you with wonder, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always gathering, always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to witness the birth of a protostar, the moment when the quiet gathering becomes a blaze of new light. The universe is waiting, and the next horizon is calling. Deep within the cold, dark heart of a molecular cloud, where gravity has been quietly gathering gas and dust for thousands or even millions of years, something extraordinary begins to happen. The material at the center of a collapsing core grows, denser and hotter, squeezed by the relentless pull of gravity. The pressure builds, the temperature rises, and a new object is born. A protostar, the universe's promise of a future sun. A protostar is not yet a true star. It is a work in progress, a glowing embryo hidden within a cocoon of dust and gas. To the naked eye, it is invisible, its light swallowed by the very cloud that gave it life. But in the infrared, astronomers can see its faint glow. A warm, gentle beacon in the darkness, a sign that creation is underway. The birth of a protostar is a story of balance and struggle. As gravity pulls material inward, the core grows hotter and denser. But as the gas falls, it also spins, flattening into a disk around the forming star. This disk is a place of chaos and creativity, where dust grains collide and stick, where gas flows in eddies, where the seeds of future planets are sown. The protostar itself is turbulent, its surface roiling with shocks and waves, its light flickering as material rains down from the disk. The protostar is hungry, feeding on the gas and dust that surround it. Streams of material spiral inward, heating up as they fall, releasing energy that escapes as infrared light. Sometimes the protostar launches powerful jets, narrow streams of gas that shoot out from its poles at hundreds of kilometers per second. These jets carve holes in the surrounding cloud, lighting up the darkness with glowing knots and filaments. The jets are a sign that the protostar is growing, shedding excess energy and angular momentum, clearing the way for the next stage of its life. But the journey from protostar to star is not easy. The protostar must gather enough mass to ignite nuclear fusion at its core, the process that will power it for millions or billions of years. If it falls short, it will become a brown dwarf, a failed star that glows faintly in the infrared, never quite reaching the brilliance of its larger siblings. Only those protostars that gather enough material, that reach the critical temperature and pressure, will make the leap to true stardom. The birth of a protostar is a race against time. The surrounding cloud is turbulent, buffeted by winds and shock waves, threatened by the radiation of nearby stars. If the protostar does not grow quickly enough, the cloud may be blown away, cutting off its supply of fuel. But if it succeeds, if it gathers enough mass, if it survives the chaos of its birth, it will ignite the fires of nuclear fusion and become a star, a new light in the darkness, a new chapter in the story of the universe. As you lie here, let yourself imagine the birth of a protostar. Picture the darkness, the cold, the swirling gas and dust. Imagine the gentle pull of gravity, the slow gathering of material, the first faint glow of infrared light. The night sky is never truly dark, for it is alive with the promise of creation, the gentle glow of possibility, the quiet hope that every shadow is a cradle, every darkness a beginning, every mystery an invitation. The birth of a protostar is also a reminder that creation is a process, not a moment. It is a story of patience, of struggle, of transformation. The universe is always becoming, always unfolding, always inviting you to look deeper, to dream farther, to wonder more. Tonight, as you rest, let the story of the protostar fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The next step in our adventure is to explore the role of turbulence and magnetic fields, the invisible forces that shape the birth of every star. The universe is waiting, and the next horizon is calling. The birth of a star is not a simple, quiet affair. It is a process shaped by invisible hands, by turbulence and magnetic fields that twist, tangle, and sculpt the clouds where stars are born. These forces are subtle, yet they are as essential to the story of creation as gravity itself. Without them, the universe would be a very different place, and the night sky would not shine with the same richness and variety. Turbulence is the restless motion of gas and dust within a molecular cloud. Imagine the way wind stirs the surface of a lake, or how cream swirls in a cup of coffee. In space, turbulence is driven by many things: the shock waves from exploding stars, the winds from massive suns, the gentle collisions of clouds drifting through the galaxy. This turbulence creates a web of filaments and knots, regions of higher and lower density, places where gravity can begin its quiet work. But turbulence is a double-edged sword. On one hand, it can help trigger star formation by compressing gas into dense clumps, making it easier for gravity to take over. On the other hand, it can also tear clouds apart, dispersing material and delaying the birth of new stars. The balance between turbulence and gravity is delicate, a cosmic dance that determines when and where stars will form. Magnetic fields are even more mysterious. They are invisible lines of force threading through the gas and dust, guiding the flow of material, shaping the structure of the cloud. Magnetic fields can support a cloud against collapse, slowing the gathering of material, or they can channel gas into narrow streams, helping to feed the growing protostar. They can twist and tangle, storing energy that is released in sudden bursts, lighting up the darkness with jets and outflows. Astronomers have learned to detect magnetic fields by studying the way light is polarized as it passes through dust grains aligned with the field. These observations reveal a hidden architecture, a network of lines and loops, a cosmic scaffolding that shapes the birth of every star. In some regions, the magnetic field is strong enough to hold back gravity, delaying the collapse of the cloud. In others, it is weak, allowing gravity to gather material more quickly. Turbulence and magnetic fields also play a crucial role in the formation of disks around young stars. As the cloud collapses, it spins faster, flattening into a disk. Turbulence stirs the disk, mixing material, helping dust grains collide and stick together. Magnetic fields can drive winds that carry away excess angular momentum, allowing the protostar to grow. These processes are essential for the birth of planets, comets, and asteroids, the building blocks of future worlds. The interplay of turbulence, magnetic fields, and gravity is complex, and astronomers are still unraveling its secrets. Computer simulations show that even small changes in these forces can lead to very different outcomes: clusters of stars, isolated suns, or clouds that never form stars at all. The universe is a place of chance and chaos, of order and beauty, of forces seen and unseen. As you lie here, let yourself imagine the hidden forces at work in a star-forming cloud. Picture the gas and dust swirling in turbulent eddies, the invisible lines of magnetic force threading through the darkness, the gentle pull of gravity gathering material into dense knots. The night sky is never truly dark, for it is alive with the energy of creation, the quiet power of forces that shape the birth of every star. Turbulence and magnetic fields are also reminders that creation is not always smooth or predictable. The universe is full of surprises, of sudden changes, of moments when order emerges from chaos. The stars we see tonight are the survivors of this cosmic dance, the children of chance and necessity, the products of a process that is both ancient and ever new. Tonight, as you rest, let the story of turbulence and magnetic fields fill you with wonder, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always moving, always changing, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the glow of infrared light, the way astronomers see the invisible and peer into the hidden nurseries where stars are born. The universe is waiting, and the next horizon is calling. The universe is filled with wonders that our eyes cannot see. Much of the story of star birth unfolds in darkness, hidden behind thick veils of dust and gas. But the cosmos has its own secret light, a gentle glow in the infrared, a wavelength longer than red, invisible to us but not to the sensitive eyes of special telescopes. Through infrared light, astronomers have learned to see the invisible, to peer into the hidden nurseries where stars are born, and to witness the earliest moments of creation. Infrared light is a kind of cosmic warmth. Every object that has heat, from a newborn star to a grain of dust, emits infrared radiation. In the cold, dark clouds where stars are born, visible light is absorbed and scattered by dust, but infrared light can slip through, carrying with it the secrets of the hidden world within. By building telescopes that can detect infrared, astronomers have opened a new window on the universe, a window that reveals the gentle glow of creation. The story of infrared astronomy is a story of patience and ingenuity. Early astronomers could only guess at what lay inside the dark clouds, but with the advent of infrared detectors, the picture changed. Telescopes like the Spitzer Space Telescope, the Herschel Space Observatory, and now the James Webb Space Telescope have revealed a universe alive with hidden light. They have shown us the warm cocoons of protostars, the swirling disks where planets are forming, the filaments and knots of gas where gravity is at work. In the infrared, the Orion Nebula is transformed. What appears as a glowing cloud invisible, light becomes a bustling nursery filled with hundreds of newborn stars, each wrapped in its own cocoon of dust. The Horsehead Nebula, a dark silhouette against a bright background, glows softly in the infrared, revealing the hidden structure of the cloud. Even the coldest, darkest regions of space are alive with warmth, with energy, with the promise of new stars. Infrared light also reveals the jets and outflows that mark the birth of a star. As material falls onto a protostar, some of it is ejected in narrow streams, carving holes in the surrounding cloud. These jets glow brightly in the infrared, lighting up the darkness with knots and filaments, tracing the paths of energy and motion. The jets are a sign that the protostar is growing. shedding excess energy, clearing the way for the next stage of its life. But seeing in the infrared is not easy. The Earth's atmosphere absorbs much of this light, so astronomers must build telescopes on high mountains, launch them into space, or fly them on airplanes above the clouds. The detectors must be cooled to near absolute zero to avoid being blinded by their own warmth. The images they produce are often false color, translating invisible wavelengths into colors we can see, painting the universe in shades of red, orange, and gold. Infrared astronomy has also revealed the presence of brown dwarfs, failed stars that never gathered enough mass to ignite nuclear fusion. These objects glow faintly in the infrared, lurking in the darkness between the stars, reminders that not every cloud becomes a sun. The universe is full of near misses, of stories that almost were, of possibilities that wait for another chance. As you lie here, let yourself imagine seeing the universe in infrared. Picture the hidden glow of dust and gas, the warm cocoons of newborn stars, the jets and outflows carving paths through the darkness. The night sky is never truly dark, for it is alive with invisible light, with the gentle warmth of creation, with the quiet hope that every shadow is a cradle, every darkness a beginning, every mystery an invitation. Infrared light is also a reminder that there is always more to see, more to know, more to love. The universe is not limited by our senses. It is always inviting us to look deeper, to build new tools, to dream new dreams. The story of star birth is a story of discovery, of patience, of the gentle unfolding of time. Tonight, as you rest, let the glow of infrared fill you with wonder, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always shining, always creating, always inviting you to look beyond the visible, to dream beyond the known, to wonder more. The next step in our adventure is to witness the collapse, the moment when a cloud becomes a star, when gravity and energy ignite the fires of creation. The universe is waiting, and the next horizon is calling. Deep within the cold, dark heart of a molecular cloud, a quiet drama unfolds. For millions of years, gravity has been gathering gas and dust, drawing it ever inward, building up a dense core. The process is slow, almost imperceptible, but relentless. And then at last, the balance tips. The pressure of gravity overcomes the resistance of gas, turbulence, and magnetic fields. The core can no longer support its own weight. Collapse begins. This collapse is the true beginning of a star's life. It is a moment of transformation, when a cloud of atoms and molecules becomes something new, a protostar, a promise of future brilliance. The collapse is not uniform. It is a dance of filaments and knots, of regions falling faster than others, of material swirling and spinning as it falls. The core grows denser and hotter, its temperature rising as gravity squeezes it tighter and tighter. As the collapse continues, the core becomes opaque to its own radiation. Heat builds up inside, trapped by the surrounding gas and dust. The temperature at the center climbs to thousands of degrees, and the pressure soars. The protostar forms at the heart of this collapsing core, a hot, dense ball of gas surrounded by a swirling disk of material. The disk is a place of chaos and creativity, where dust grains collide and stick, where gas flows and eddies, where the seeds of future planets are sown. But the collapse is not a simple, smooth process. It is shaped by turbulence, by magnetic fields, by the angular momentum of the cloud. As the core spins, it flattens into a disk, conserving angular momentum. Material spirals inward, feeding the growing protostar, while some is ejected in powerful jets that shoot out from the poles. These jets carve holes in the surrounding cloud, lighting up the darkness with glowing knots and filaments. The collapse continues until the pressure and temperature at the core become high enough to ignite. Nuclear fusion, the process that will power the star for millions or billions of years. But before that moment, the protostar is still hidden, wrapped in layers of dust and gas, its light a secret kept by the darkness. Only in the infrared can astronomers glimpse the faint glow of the forming star, a promise of the brilliance to come. The timescale of collapse depends on the mass and density of the core. For a typical star like the Sun, the process takes a few 100,000 years. a blink of an eye in cosmic terms, but an eternity for the atoms and molecules caught in the dance. For more massive stars, the collapse is faster and more violent, while for smaller stars, it is slower and more gentle. The collapse is also a moment of decision. If the core gathers enough mass, it will become a true star, igniting nuclear fusion and shining for millions or billions of years. If it falls short, it will become a brown dwarf, a failed star that glows faintly in the infrared, never quite reaching the brilliance of its larger siblings. The universe is full of near misses, of stories that almost were, of possibilities that wait for another chance. As you lie here, let yourself imagine the collapse of a star-forming core. Picture the darkness, the cold, the swirling gas and dust. Imagine the gentle pull of gravity, the slow gathering of material, the first faint glow of infrared light. The night sky is never truly dark, for it is alive with the promise of creation, the gentle glow of possibility, the quiet hope that every shadow is a cradle, every darkness a beginning, every mystery an invitation. The collapse is also a reminder that creation is a process, not a moment. It is a story of patience, of struggle, of transformation. The universe is always becoming, always unfolding, always inviting you to look deeper, to dream farther, to wonder more. Tonight, as you rest, let the story of collapse fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to witness the first light, the ignition of nuclear fusion, the moment when a protostar becomes a true star. The universe is waiting, and the next horizon is calling. At the heart of every star, there is a moment of transformation, a moment when darkness gives way to light, when the quiet gathering of gas and dust becomes a blaze of energy that will shine for millions or billions of years. This is the ignition of nuclear fusion, the true birth of a star, the first light that marks the beginning of a new chapter in the universe's story. As the collapsing core of a protostar grows denser and hotter, the pressure at its center rises to unimaginable levels. At first, the heat is trapped, unable to escape through the thick cocoon of gas and dust. But as the temperature climbs past a few million degrees, something extraordinary happens. The hydrogen atoms at the core begin to move so fast and collide so violently that they overcome their natural repulsion and fuse together. This process, nuclear fusion, releases a tremendous amount of energy in the form of light and heat. Fusion is the engine that powers every star. It is the process by which hydrogen is transformed into helium, releasing energy that pushes outward against the force of gravity. For the first time, the star achieves balance. The inward pull of gravity is matched by the outward pressure of fusion. The star is born, stable and shining, a new light in the darkness. The ignition of fusion is not a sudden flash, but a gradual awakening. The core grows hotter and denser. The rate of fusion increases, and the energy begins to leak outward, first as infrared light, then as visible light. The protostar sheds its cocoon, blowing away the surrounding gas and dust with powerful winds and radiation. The jets that once carved holes in the cloud fade away, replaced by a steady, gentle glow. The star emerges, visible for the first time, a beacon in the night. The first light of a new star is a moment of celebration, not just for the universe, but for all the worlds and lives that will one day depend on its energy. The light travels outward, crossing the vastness of space, illuminating the dust and gas that remain, triggering new waves of star formation, setting off a chain reaction that echoes across the galaxy. The birth of one star can lead to the birth of many, as the energy and winds from the newborn sun compress nearby clouds, creating new seeds for future stars. But the ignition of fusion is also a moment of change. The star's environment is transformed. The balance of forces shifts, and the story enters a new phase. The star will spend most of its life in this stable state, fusing hydrogen into helium, shining steadily, nurturing any planets that may form in its orbit. The details of its life, how long it will shine, how bright it will be, what kind of worlds it will host, are determined by its mass, its composition, and the environment in which it was born. For massive stars, the ignition of fusion is a brief, brilliant affair. These giants burn through their fuel quickly, shining with fierce energy, living fast and dying young. For smaller stars, like our Sun, the process is slower and more gentle, a long, steady glow that can last for billions of years. The smallest stars, the red dwarfs, burn so slowly that they may outlive the universe itself, shining faintly for trillions of years. As you lie here, let yourself imagine the first light of a newborn star. Picture the darkness, the cold, the swirling gas and dust. Imagine the sudden, gentle glow at the core, the energy pushing outward, the cocoon of dust and gas blown away, the star emerging into the night. The sky is never truly dark, for it is alive with the light of new beginnings, the gentle glow of creation, the quiet hope that every shadow is a cradle, every darkness a promise, every mystery an invitation. The ignition of fusion is also a reminder that creation is a process, not a moment. It is a story of patience, of struggle, of transformation. The universe is always becoming, always unfolding, always inviting you to look deeper, to dream farther, to wonder more. Tonight, as you rest, let the story of the first light fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the T Tauri phase, a star's turbulent youth, a time of change and chaos before the calm of maturity. The universe is waiting, and the next horizon is calling. At the birth of a star is not the end of its story, but the beginning of a new and restless chapter. After the first light of nuclear fusion ignites at its core, a young star enters a period of wild, unpredictable change, a cosmic adolescence known as the T Tauri phase. Named after a star in the constellation Taurus, this stage is a time of turbulence, outbursts, and transformation, when the newborn sun is still finding its balance, still shaping its future. Tauri stars are young, just a few million years old, and they shine with a light that flickers and flares. Their surfaces are covered in spots, their brightness varies from night to night, and their winds are fierce, blowing away the last remnants of the cloud that gave them birth. These stars are larger and cooler than they will be as adults, their energy coming not just from fusion, but from the heat of contraction as they settle into their final size. The T Tauri phase is a time of chaos and creativity. The star is still, surrounded by a disk of gas and dust, the leftovers from its formation. This disk is a place of constant motion, where material spirals inward, feeding the star, while other material is blown outward by powerful winds and jets. The disk is also the birthplace of planets, comets, and asteroids, as dust grains collide and stick, growing into pebbles, rocks, and eventually worlds. The young star's magnetic field is strong and tangled, reaching out into the disk, channeling material onto the star's surface in bright, hot spots. These magnetic fields can twist and snap, releasing bursts of energy that light up the star's surroundings. The result is a star that is anything but calm, a sun that flickers, flares, and changes from moment to moment. Astronomers study T Tauri stars to understand the earliest stages of stellar evolution. By observing their light, their winds, and their disks, scientists can piece together the story of how stars grow, how planets form, and how the chaos of youth gives way to the calm of maturity. The T Tauri phase is short-lived, lasting just a few million years, but it is a time of profound change, a time when the future of the star and its planetary system is decided. For the planets forming in the disk, the T Tauri phase is a time of danger and opportunity. The star's winds can blow away the gas in the disk, shaping the orbits of planets, determining which worlds will become gas giants and which will remain rocky. The energy from the young star can heat the disk, driving chemical reactions that create the building blocks of life. The collisions and mergers of planetesimals can create moons, rings, and the seeds of future worlds. The T Tauri phase is also a time of beauty. The disks around these young stars glow in the infrared, their shapes sculpted by the winds and jets from the star. In some cases, astronomers can see gaps and rings in the disk, signs that planets are already forming, carving paths through the dust, shaping the future of the system. The images are haunting, a glimpse into the earliest moments of creation, a reminder that every star, every planet, every world has a story that begins in chaos and ends in light. As you lie here, let yourself imagine the life of a T-Tauri star. Picture the flickering light, the swirling disk, the powerful winds and jets. Imagine the chaos and creativity, the collisions and mergers, the birth of planets and moons. The night sky is never truly dark, for it is alive with the energy of youth, the gentle glow of possibility, the quiet hope that every star, every world, every dream is shaped by the turbulence of creation. The T-Tauri phase is a reminder that growth is not always smooth or easy. The universe is full of change, of struggle, of moments when order emerges from chaos. The stars we see tonight are the survivors of this cosmic adolescence, the children of chance and necessity, the products of a process that is both ancient and ever new. Tonight, as you rest, let the story of the T-Tauri star fill you with wonder, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always changing, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the dance of disks, the swirling material around young stars where planets are born, and where the seeds of future worlds are sown. The universe is waiting, and the next horizon is calling. Stars are rarely born alone. In the vast, cold nurseries of the galaxy, gravity gathers gas and dust into great clouds. And when these clouds collapse, they often give birth to dozens, hundreds, or even thousands of stars at once. These newborn stars form what astronomers call star clusters, families of light bound together by gravity and by the shared story of their origin. Imagine a region of space where the darkness is pierced by 1,000 points of light, each one a newborn star, shining with youthful energy. Some are massive and blue, burning hot and bright. Others are smaller and red, destined for long, quiet lives. The stars in a cluster are siblings, born from the same cloud, sharing the same chemical fingerprint, the same cosmic heritage. For a time, they move together through the galaxy, a family drifting on the currents of the Milky Way. There are two main types of star clusters, open clusters and globular clusters. Open clusters are loose, irregular gatherings of young stars, often found in the spiral arms of galaxies. The Pleiades, or Seven Sisters, is one of the most famous open clusters, visible to the naked eye as a tiny dipper of blue-white stars. Open clusters are short-lived on cosmic timescales. Over millions of years, the stars drift apart, scattered by gravitational encounters and the tidal forces of the galaxy. Globular clusters, on the other hand, are ancient and tightly bound. These spherical swarms contain hundreds of thousands, sometimes millions of stars, packed into a region just a few dozen light years across. Globular clusters orbit the outskirts of galaxies, relics from the earliest days of the universe. Their stars are old, red, and metal-poor, fossils from a time when the cosmos was young and the first generations of stars were forming. Star clusters are laboratories for understanding the life cycles of stars. Because the stars in a cluster are born at the same time and from the same material, astronomers can compare their masses, colors, and brightness to learn how stars evolve. The most massive stars burn out quickly, exploding as supernovae and enriching the cluster with heavy elements. The smaller stars live longer, shining steadily for billions of years, their fates written in the patterns of the cluster. Clusters are also places of beauty and wonder. Through a telescope, an open cluster looks like a handful of diamonds scattered on black velvet, each star a tiny sun, each one a world of possibility. Globular clusters are even more breathtaking, dense, glowing spheres of light, shining with the combined brilliance of a million stars. To look at a cluster is to see the universe in miniature, a family of suns bound together by gravity and by the memory of their birth. But clusters do not last forever. Over time, the stars in an open cluster drift apart, becoming part of the general population of the galaxy. Even globular clusters, though more tightly bound, are slowly eroded by the tidal forces of the Milky Way. their stars escaping one by one into the darkness. The family disperses, but the memory remains, written in the motions and compositions of the stars. As you lie here, let yourself imagine drifting through a star cluster. Picture the sky filled with light, the stars shining all around you, the sense of belonging to a family, a community, a story larger than yourself. The night sky is never truly dark, for it is alive with the light of clusters, the gentle glow of shared origins, the quiet hope that every star, every world, every dream is part of a greater whole. Star clusters are also reminders of our own connections. Just as stars are born together and drift apart, so too do people come together, share a journey, and then move on. The universe is a place of meetings and partings, of families and friendships, of stories that intertwine and then diverge. The beauty of a cluster is not just in its light, but in its story, a story of togetherness, of change, of the gentle unfolding of time. Tonight, as you rest, let the story of star clusters fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the life cycle of stars, how massive and small stars live, change, and ultimately return their gifts to the cosmos. The universe is waiting, and the next horizon is calling. Every star, no matter how bright or faint, is born with a destiny written in its mass. The life cycle of a star is a story of transformation, of change, of giving and receiving. It is a journey that begins in darkness, blazes with light, and ends in a return to the cosmic clouds from which it came. Yet, not all stars live the same story. The path of a massive star is wild and brief, while the journey of a small star is gentle and long. Let's begin with the massive stars, the giants of the cosmos. These stars are born with at least 8 times the mass of our sun, and they burn with a fierce, blue-white light. Their lives are short by cosmic standards, lasting only a few million years. Massive stars are prodigious engines of fusion, turning hydrogen into helium, then fusing heavier and heavier elements in their cores. As they age, they swell into supergiants, their outer layers expanding, their cores growing ever hotter and denser. The end of a massive star's life is spectacular. When the core runs out of fuel, it collapses in a fraction of a second, triggering a supernova explosion, a burst of energy so powerful it can outshine an entire galaxy. The outer layers are blasted into space, enriching the surrounding clouds with heavy elements: carbon, oxygen, iron, gold. The core that remains may become a neutron star, a city-sized sphere of pure nuclear matter, spinning and pulsing with unimaginable energy. Or, if the star is massive enough, the core collapses into a black hole, a region of space where gravity is so strong that not even light can escape. These explosions are not just endings, they are beginnings. The material ejected by supernovae seeds the galaxy with the ingredients for new stars, planets, and life. The shock waves from the explosion can trigger the collapse of nearby clouds, setting off new waves of star formation. The life of a massive star is a story of giving, of returning its gifts to the cosmos, of lighting the way for the next generation. Now let's turn to the small stars, the red dwarfs, the most common stars in the universe. These stars are born with less than half the mass of the sun, and they burn their fuel slowly and steadily. A red dwarf can shine for trillions of years, far longer than the current age of the universe. Their light is faint, their lives are quiet, but their endurance is unmatched. When a red dwarf finally runs out of fuel, it simply cools and fades, becoming a cold, dark remnant, a black dwarf, a star that has lived its life in peace. Stars like our sun fall somewhere in between. They spend most of their lives fusing hydrogen into helium, shining steadily for billions of years. When the hydrogen in the core is exhausted, the star swells into a red giant, its outer layers expanding, its core contracting and heating. The star sheds its outer layers in a gentle wind, creating a beautiful planetary nebula, a glowing shell of gas that drifts away into space. The core that remains becomes a white dwarf, a hot, dense ember that will cool and fade over billions of years. The life cycle of a star is a story of transformation, of change, of return. Every atom in your body was forged in the heart of a star, scattered across the galaxy, gathered into clouds, and born again in new suns and planets. You are, quite literally, made of stardust, a child of the cosmos, a participant in the endless cycle of creation and renewal. As you lie here, let yourself imagine the life of a star. Picture the darkness of its birth, the brilliance of its youth, the changes of its middle age, the drama of its death, and the quiet peace of its return to the clouds. The night sky is never truly dark, for it is alive with the light of stars at every stage of life. The gentle glow of possibility, the quiet hope that every ending is a beginning, every death a promise, every mystery an invitation. The life cycle of stars is also a reminder that change is natural, that endings are not to be feared, that every moment is part of a larger story. The universe is always becoming, always unfolding, always inviting you to look deeper, to dream farther, to wonder more. Tonight, as you rest, let the story of the stars fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the role of supernovae in star birth, how the death of one star can spark the birth of many, and how the cycle of creation continues. The universe is waiting, and the next horizon is calling. In the grand cycle of the cosmos, endings are never truly final. Nowhere is this more evident than in the story of supernovae, the spectacular deaths of massive stars that, paradoxically, sow the seeds for new generations of stars. A supernova is not just an explosion. It is a cosmic gardener, scattering the elements of life and stirring the clouds where new stars will one day be born. When a massive star reaches the end of its life, its core collapses in a fraction of a second, triggering a supernova explosion. The outer layers are blasted into space at incredible speeds, creating shockwaves that ripple through the surrounding interstellar medium. These shockwaves are powerful enough to compress nearby clouds of gas and dust, triggering the collapse that leads to star formation. In this way, the death of one star can spark the birth of many, a cosmic chain reaction that echoes across the galaxy. The material ejected by a supernova is rich in heavy elements: carbon, oxygen, silicon, iron, gold, and more. These elements are the building blocks of planets, moons, and life itself. Without supernovae, the universe would be a simpler, poorer place, lacking the diversity and complexity that make worlds like Earth possible. Every atom of iron in your blood, every molecule of calcium in your bones, was forged in the heart of a massive star and scattered by a supernova long before the sun was born. Supernovae also play a crucial role in shaping the structure of galaxies. The energy released in these explosions stirs the interstellar medium, creating bubbles and cavities, mixing gas and dust, and setting the stage for new waves of star formation. The shock waves can trigger the collapse of molecular clouds, compressing them into dense knots where gravity can take over. In some cases, a single supernova can light up a region of space, creating a glowing nebula that will one day give birth to new stars. Astronomers have observed the aftermath of supernovae in many forms. The Crab Nebula, for example, is the remnant of a supernova seen on Earth in 1054. Its filaments and knots are the remains of a massive star, still glowing with energy nearly 1,000 years after the explosion. The Veil Nebula, the Cygnus Loop, and Cassiopeia A are other examples, cosmic tapestries woven from the threads of destruction and creation. But supernovae are not just about violence and chaos. They are also about renewal and hope. The elements scattered by these explosions enrich the clouds from which new stars and planets will form. The shock waves stir the gas, mixing the ingredients of life, setting the stage for the next generation. The universe is always recycling, always renewing, always turning endings into beginnings. Supernovae also serve as cosmic beacons, marking the passage of time and the evolution of galaxies. By studying the light from these explosions, astronomers can measure distances across the universe, trace the expansion of space, and probe the history of star formation. Supernovae are among the brightest events in the cosmos, visible across billions of light years, their light carrying messages from the distant past. As you lie here, let yourself imagine the life and death of a massive star. Picture the brilliance of its youth, the swelling of its final days, the sudden, spectacular explosion that scatters its material across the galaxy. Imagine the shock waves rippling through space, compressing clouds, triggering the birth of new stars. The night sky is never truly dark, for it is alive with the echoes of supernovae, the gentle glow of renewal, the quiet hope that every ending is a beginning, every death a promise, every mystery an invitation. The role of supernovae in star birth is a reminder that the universe is a place of cycles, of transformation, of endless possibility. The atoms in your body were forged in the heart of a star, scattered by a supernova, gathered into clouds, and born again in the sun and earth. You are, quite literally, made of stardust, a participant in the grand cycle of creation and renewal. Tonight, as you rest, let the story of supernovae fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the cosmic recycling of stardust, the way each generation of stars enriches the next, and how the story of creation is written in the elements of life. The universe is waiting, and the next horizon is calling. The universe is a master of recycling. Nothing is wasted, nothing is lost. Every atom, every grain of dust, every whisper of energy is part of a grand cycle that connects the birth and death of stars, the formation of planets, and the emergence of life. This cosmic recycling is the reason the night sky is never truly dark, for it is alive with the echoes of past generations, the gentle glow of stardust, the quiet promise that every ending is a new beginning. When a star dies, whether in a gentle wind or a violent supernova, it returns its material to the galaxy. The gas and dust ejected by dying stars drift through space, mixing with the interstellar medium, enriching it with heavy elements. These elements are the building blocks of everything: carbon for life, oxygen for breath, iron for blood, silicon for rocks, gold for beauty. The universe is always gathering, always blending, always preparing the ingredients for the next generation. Over millions of years, this recycled material collects in molecular clouds, vast, cold regions where gravity can begin its quiet work. The clouds are not pure hydrogen and helium, as they were in the early universe, but are laced with the ashes of countless stars. Every new star, every new planet, every new world is born from this enriched material, carrying within it the memory of all that came before. The process of cosmic recycling is not just about matter, it is also about energy. The light from dying stars heats the surrounding gas, driving chemical reactions that create complex molecules: water, ammonia, methane, and even the precursors of life. The shock waves from supernovae stir the clouds, triggering new waves of star formation, setting off a chain reaction that echoes across the galaxy. The universe is always in motion, always transforming, always turning the old into the new. Astronomers have observed the evidence of cosmic recycling. In many ways, the spectra of stars reveal the fingerprints of heavy elements, showing that each generation is richer than the last. The dust in molecular clouds glows in the infrared, revealing the presence of complex molecules and organic compounds. Meteorites that fall to Earth contain grains older than the sun, tiny time capsules from the earliest days of the galaxy. The story of cosmic recycling is also the story of life. The atoms in your body were forged in the hearts of ancient stars, scattered by supernovae, gathered into clouds, and born again in the sun and earth. You are, quite literally, made of stardust, a participant in the endless cycle of creation and renewal. Every breath you take, every thought you think, every dream you dream is part of a story that began long before you and will continue long after. Cosmic recycling is a reminder that the universe is a place of connection, of continuity, of hope. The stars we see tonight are the children of stars that lived and died billions of years ago. The planets that circle those stars are made from the ashes of ancient suns. The life that may exist on those planets is part of the same cycle, the same story, the same gentle unfolding of time. As you lie here, let yourself imagine the journey of a single atom. Born in the fire of a star, it is scattered into space, drifts through the galaxy, joins a cloud, becomes part of a new star, a new planet, a new life. The night sky is never truly dark, for it is alive with the memory of creation, the gentle glow of possibility, the quiet hope that every atom, every grain of dust, every whisper of energy is part of a story that is always unfolding. Cosmic recycling is also a lesson in humility and gratitude. We are not separate from the universe, but part of it, connected to the stars, to the clouds, to the cycles of birth and death that shape the cosmos. The universe is always inviting us to look deeper, to dream farther, to wonder more. Tonight, as you rest, let the story of cosmic recycling fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the colors of nebulae, the glowing clouds that light up the night, each one a masterpiece painted by the elements of creation. The universe is waiting, and the next horizon is calling. The universe is not only a master of recycling, but also a master artist. Nowhere is this more evident than in the colors of nebulae, those glowing clouds that light up the night with their ethereal beauty. Each nebula is a masterpiece, painted by the elements of creation, illuminated by the energy of stars, and shaped by the interplay of light and shadow. The colors of nebulae are not just beautiful, they are clues to the processes that shape the cosmos, the chemistry of life, and the birth of stars. There are three main types of nebulae, each with its own palette: emission nebulae, reflection nebulae, and dark nebulae. Each type tells a different story, each one a chapter in the cosmic tale of creation. Emission nebulae are the most dramatic, glowing with the light of ionized gas. These nebulae are often found near hot young stars, whose intense ultraviolet radiation strips electrons from atoms, causing the gas to shine in brilliant reds, pinks, and greens. The most famous emission nebula is the Orion Nebula, a glowing cradle where hundreds of stars are being born. The red color comes from hydrogen, the most abundant element in the universe, while greens and blues are produced by oxygen and other elements. The light from an emission nebula is a sign of energy, of creation, of the birth of new stars. Reflection. Nebulae are more subtle, shining not with their own light but with the light of nearby stars reflected off tiny dust grains. These nebulae often appear blue because blue light scatters more easily than red. The Pleiades, a cluster of young stars surrounded by a faint blue haze, is a beautiful example of a reflection nebula at work. The light from a reflection nebula is a sign of connection, of the interplay between stars and clouds, of the gentle scattering of energy across the cosmos. Dark nebulae are the most mysterious, clouds so thick with dust that they block the light of stars behind them, creating inky silhouettes against the brighter background. The Horsehead Nebula, with its iconic shape, is one of the most famous dark nebulae, a shadowy figure standing guard in the constellation Orion. These dark clouds are the true wombs of starbirth, hiding the earliest stages of creation from prying eyes. The darkness of a nebula is a sign of potential, of secrets waiting to be revealed, of the quiet promise of new beginnings. The colors of nebulae are not just a matter of beauty. They are a language, a code that astronomers have learned to read. By studying the light from a nebula, scientists can determine its composition, its temperature, its density, and its history. The spectra of nebulae reveal the fingerprints of hydrogen, helium, oxygen, nitrogen, and other elements, each one a clue to the processes at work. The colors tell us where stars are being born, where they are dying, where the cycle of creation is unfolding. But the colors of nebulae are also a reminder that the universe is always changing. always becoming. The clouds we see today will not last forever. Some will collapse to form new stars. Others will be blown apart by stellar winds. Still others will drift quietly, waiting for their moment. The story of a nebula is the story of transformation, of patience, of the gentle unfolding of time. As you lie here, let yourself imagine drifting through a nebula. Picture the colors, soft reds and pinks, deep blues and purples, glowing greens and golds. Imagine the silence, the vastness, the sense of possibility. The night sky is never truly dark, for it is alive with the light of nebulae, the gentle glow of creation, the quiet hope that every cloud is a cradle, every shadow a promise, every mystery an invitation. The colors of nebulae are also a reminder that beauty is everywhere, even in the darkest places. The universe is a place of contrasts, of light and shadow, of energy and stillness, of creation and destruction. The beauty of a nebula is not just in its colors, but in its story. A story of connection, of transformation, of the endless dance of matter and energy. Tonight, as you rest, let the colors of nebulae fill you with wonder, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always painting, always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the human connection to the stars, the way our atoms were forged in cosmic clouds, and how we are, quite literally, made of stardust. The universe is waiting, and the next horizon is calling. As you lie beneath the night sky, gazing up at the stars, it's easy to feel small, just one person on one planet, lost in the immensity of the cosmos. But the truth is far more wondrous. You are not separate from the universe, but deeply, intimately connected to it. Every atom in your body, every breath you take, every thought you think, is part of a story that began in the heart of a star. You are, quite literally, made of stardust. The hydrogen in your body, the simplest, most ancient element, was born in the first few minutes after the Big Bang, when the universe was still a hot, dense soup of particles. But the heavier elements, carbon, oxygen, nitrogen, calcium, iron, were forged in the hearts of stars, in the nuclear furnaces that power their light. When those stars died, they returned their material to the galaxy, scattering it across space in gentle winds or violent supernovae. That stardust drifted through the galaxy, gathered into clouds, and was born again in new stars, new planets, new life. The iron in your blood was forged in the core of a massive star, then scattered by a supernova long before the sun was born. The calcium in your bones, the oxygen in your lungs, the carbon in your cells, all were created in the hearts of stars, then recycled through the galaxy, gathered into the cloud that became the sun and earth. Every breath you take, every heartbeat, every dream is a continuation of the story of the stars. This connection is not just poetic, it is scientific fact. Astronomers have measured the abundances of elements in stars, in meteorites, in the earth, and in the human body. The patterns match. The atoms that make up your body are the same atoms that make up the stars, the planets, the clouds, the dust. The universe is not just out there, it is within you, woven into the fabric of your being. But the connection goes deeper still. The processes that shape the birth and death of stars, the gathering of clouds, the ignition of fusion, the recycling of stardust, are the same processes that make life possible. The energy that powers your body comes from the sun, a star born in a cosmic cloud. The water you drink was formed in the cold depths of space, carried to Earth by comets and asteroids. The molecules that make up your DNA were assembled from atoms forged in ancient stars. You are not just a spectator in the universe, you are a participant, a product, a continuation of its story. The atoms in your body have traveled across the galaxy, through clouds and stars, through birth and death, through darkness and light. You are a child of the cosmos, a traveler on the road of stardust, a participant in the endless cycle of creation and renewal. This connection is a source of wonder, of humility, of gratitude. It is a reminder that you are never truly alone, that you are part of something vast and beautiful, that your story is woven into the story of the universe. The night sky is never truly dark, for it is alive with the light of your own origins. The gentle glow of possibility, the quiet hope that every atom, every breath, every dream is part of a story that is always unfolding. As you lie here, let yourself feel the connection to the stars. Imagine the journey of a single atom, from the heart of a star, to the dust of a cloud, to the water in your body, to the breath you exhale. The universe is always creating, always recycling, always inviting you to look deeper, to dream farther, to wonder more. The human connection to the stars is also a source of inspiration. It is the reason we look up, the reason we ask questions, the reason we dream of other worlds. The universe is not just a place, it is a story, a journey, a home. The next step in our adventure is to explore the poetry of starbirth in myth and imagination, the ways in which people have told the story of the stars, and the ways in which the stars have shaped the stories we tell. The universe is waiting, and the next horizon is calling. Long before telescopes, before equations, before the language of science, the birth of stars was a story told in whispers and wonder. The night sky was a living tapestry, embroidered with gods and monsters, heroes and lovers, omens and dreams. Every culture, every people, every family has woven its own myths into the fabric of the cosmos, turning the stars into a memory palace, a map of belonging, a source of hope. In ancient times, the birth of a star was a miracle, a sign from the heavens, a message from the gods. The Greeks imagined the Milky Way as the milk of Hera, spilled across the sky as she nursed the infant Heracles. The Egyptians saw the stars as the souls of the dead, sailing with Ra through the underworld, reborn each night in the east. The Chinese told of the weaver girl and the cowherd, lovers separated by the Silver River, allowed to meet only once a year when magpies formed a bridge of stars. The Aboriginal peoples of Australia saw the dark spaces between the stars as emus and serpents, their stories written not in light, but in shadow. The Navajo imagined the stars as holes in the sky, through which the light of the next world shines. The Polynesians navigated by the stars, reading their positions as a map of the ocean, a guide to new lands, a promise of home. The poetry of starbirth is not just about the past. Even now, in a world of city lights and glowing screens, the night sky calls to us. We gather for meteor showers, for eclipses, for the rare dance of planets. We make wishes on shooting stars. We search for meaning in the patterns above. The myths may be quieter, but they are not gone. They live in the stories we tell our children, in the songs we sing, in the silent awe that fills us when we see the Milky Way on a dark, clear night. Imagination, too, is a kind of telescope, a way of seeing farther, of reaching beyond the limits of knowledge, of dreaming what might be. Science fiction writers have imagined stars being born in nebulae of living light, or in the hearts of dying giants. Artists have painted the cosmos in colors no eye has seen. Poets have written verses that capture the longing, the hope, the gentle ache of wanting to know what lies beyond. The poetry of starbirth is a story of connection. It is the recognition that we are not separate from the universe, but part of it, woven from the same atoms, shaped by the same forces, inspired by the same mysteries. The stars are not just out there, they are within us, in our stories, our dreams, our longing for meaning. As you lie here, let yourself drift into the poetry of starbirth. Remember the stories you have heard, the dreams you have dreamed, the moments you have felt the world grow larger and more mysterious. The darkness above is not empty. It is full of meaning, full of hope, full of the gentle presence of all who have ever wondered. The night sky is never truly dark, for it is alive, with memory, with myth, with the quiet promise that you are part of something vast and beautiful. The stories of the stars are your stories. The dreams of the night are your dreams. The gentle darkness is your home. Tonight, as you rest, let the sky hold your memories, your questions, your wonder. The universe is waiting, and the next story is always about to begin. Imagination is also a bridge to the future. The questions we ask today become the discoveries of tomorrow. The dreams we dream tonight become the realities of the next generation. The universe is not finished. It is always becoming, always unfolding, always inviting us to look deeper, to dream farther, to wonder more. So as you rest, let the poetry of star birth fill you with peace, with gratitude, with the quiet joy of not knowing. The edge is always moving, always inviting, always waiting for you to ask, what if, and why not, and what else is there? The journey is never finished, the story is never complete, the adventure is always just beginning. The next and final step in our adventure is to rest in the gentle light of newborn stars, to let the universe sing you to sleep, to dream of creation, and to know that you are home, always, in the light of the cosmos. Here, at the end of our journey, the universe grows quiet. The questions have been asked, the mysteries explored, and the gentle darkness of night settles in. You have traveled far, across clouds and clusters, through the birth and death of stars, to the very heart of creation. Now, it is time to rest, to let the universe cradle you in its vast, luminous arms, and to dream in the gentle light of newborn stars. Imagine yourself lying beneath the open sky, the world hushed around you, the air cool and calm. Above, the Milky Way stretches on and on, a river of starlight flowing across the heavens. Each star is a lullaby, a note in the music of creation, a gentle promise that you are not alone. The edge of darkness is close tonight, not far away in the unreachable beyond, but here, within your own quiet wonder. Let the silence of the universe wrap around you like a blanket. Feel the slow turning of the earth, the soft pull of gravity, the steady rhythm of your breath. You are part of the cosmos, a child of stardust, a traveler on the road to infinity. The edge is not a place to fear, but a place to cherish, a gentle reminder that you belong to something vast and beautiful. As you rest, listen for the lullaby of the stars. It is the hum of atoms, the whisper of light, the soft sigh of galaxies drifting apart. It is the memory of the first dawn, the echo of the oldest light, the promise of new beginnings. The universe sings in silence, in darkness, in the spaces between stars. Its song is patient, timeless, full of hope. The light of newborn stars is a gentle glow, a promise that creation is always beginning, always unfolding, always inviting you to look deeper, to dream farther, to wonder more. In dreams, you can cross any horizon, visit any world, ask any question. The edge becomes a playground, a canvas for your imagination, a place where anything is possible. Tonight, let your thoughts drift with the stars. Imagine the galaxies spinning in their slow, graceful waltz. Imagine the light traveling for billions of years, carrying stories from the farthest reaches of time. Imagine the universe as a great, gentle ocean, its waves lapping softly at the shore of your mind. The edge is not a line, but a feeling, a sense of wonder, a breath of peace, a whisper of infinity. The cosmic lullaby is not just for the stars, it is for you. It is the comfort of knowing that you are part of a story that began long before you and will continue long after. It is the joy of belonging to a universe that is always growing, always changing, always inviting you to dream. It is the peace of resting at the edge, of letting go of questions, of trusting that the journey is enough. As you drift towards sleep, let the universe hold you. Let the light of newborn stars cradle your dreams. Let the galaxies guard your rest. Let the silence fill you with calm. The night is long, but you are safe. The cosmos is vast, but you are home. The edge is always near, always waiting, always ready to welcome you back. In this quiet moment, know that you are not alone. All over the world, people are listening to the same lullaby, dreaming the same dreams, asking the same questions. The edge connects us across time and space, across cultures and generations. It is the place where our stories begin and where they are always unfolding. The universe is a gentle teacher. It reminds you that every ending is a beginning, that every edge is a doorway, that every night is a promise of dawn. The cosmic lullaby is a song of hope, a melody of wonder, a hymn to the infinite. It is the music of the spheres, the poetry of the stars, the gentle hum of existence. So rest now, traveler. Let the light of newborn stars be your pillow, the galaxies your blanket, the silence your song. Let the questions wait until morning. Let the dreams carry you beyond the horizon. Let the peace of the cosmos fill your heart. The journey is never finished. The story is never complete. The adventure is always just beginning. Sleep well, gentle soul. The universe is with you, whispering its secrets, singing its lullaby, inviting you to dream of clouds and stars, of journeys and homecomings, of infinity and love. Tonight, as you close your eyes, know that you are resting in the light of newborn stars, not just at the edge of the universe, but at the heart of creation, at the beginning of every story, at the threshold of every dream. The cosmic lullaby will carry you through the night, and when you wake, the stars will still be there, waiting for your next question, your next dream, your next gentle step into the unknown.